Welcome to the Elektromotorenwerk in Bad Neustadt. Today I want to give you a detailed introduction to our automatic pallet warehouse. A digital twin is essential for the improved planning, optimal design, and ongoing inspection of warehouse systems. Siemens software products provide you with optimal support, both during the planning phase prior to the warehouse's construction, and during the phase when order structures have to be adapted and workflows can change. Will throughput quantities be achieved? Or can it also be done using less resources? Today we want to describe the advantages of this digital twin using the example of an automatic pallet warehouse, and at the same time take a look at the technology inside the control cabinet. We'll see how state-of-the-art digital technology can be used to support operations and optimize plants. Want to know more? Then let's get right down to it. Here we see the planning of a warehouse using plant simulation. Taking into account known characteristic values like the number of incoming and outgoing pallets per hour and the different processing times for different order types, we can identify the optimal number and arrangement of workstations by running several simulations. The result is an efficient material flow and an extremely economical design. In our specific case, we considered the number and utilization of workstations as well as goods retrieval by the automated guided vehicle system. The result of the simulation phase was an economical implementation with only 2 workstations and a utilization of over 80%. Now let's see where the pallets are stored. After delivery, the pallets are placed on the conveyor system. Each pallet is scanned, inspected, and then put away. Any pallets that are defective, unknown, or empty are ejected at the exit on the left side. The roller conveyor system, driven by Siemens drives and motors, transports the pallets from their storage locations to the picking locations. In the process, we collect a lot of data that we can use for performing predictive maintenance on the plant. The manual picking stations are equipped with ergonomic workbenches that can be lowered if necessary. Containers that are too heavy can be moved by a crane. The conveyor system transports pallets that are to be retrieved completely to a special pickup station, from which they can then be transported to their destination by the automated guided vehicles. Goods are stored and retrieved in 3 aisles. The storage and retrieval machine can store the pallets double deep. This is where the latest Siemens drives, motors, and controllers come into play. They supply us with a tremendous amount of data on the plant's usage and energy consumption. Each storage and retrieval machine is monitored by a Siemens Industrial Edge, which uses its computing power not only to read the usage data, but also to enable predictive maintenance based on analysis of drive data and the use of artificial intelligence, all of which helps reduce downtime. The connection to MindSphere is inside the central control cabinet. This is where status information from all parts of the warehouse is gathered and made available in the cloud, thus providing us with detailed information on energy consumption, travel paths, and overall plant availability and utilization. Based on the data acquired, not only can we view the latest data on our dashboard, but we can also make predictions about necessary maintenance work based on the data obtained and evaluated in order to prevent downtimes during operation. In addition to informing us about the total amount of energy consumed, the energy values also tell us that since commissioning, around 20% of the kilowatt hours obtained through energy recovery have been fed back into the system. With our highly automated pallet warehouse, we've been able to use digitalization to design a more efficient receiving process and store more materials in less space.